Okay, here we go. This is a chapter on probability. Okay, and what we're working on right now is probability of multiple events. Okay, now this is actually chapter 11.3. We're skipping around here. We're not going to do much on probability, but we're going to do a couple lessons, 11.3 and 11.4. I kind of thought, before I start this, I thought I would just remind you what probability is. Probability is simply the success of what you want to happen out of the total outcomes that could happen. For instance, probability, I usually put P for probability, and then inside my parentheses I'll say what I want. And if I said that I want the probability of rolling a 6-sided die, and I want what's the probability that I roll a 3? Okay, well, the success is the number of 3s on a 6-sided die. Since there's only one, it's 1 out of the total outcomes, 6-sided die, 1 out of 6. So this is your probability of rolling a 3 when you roll a die, or you could just change it over to a percentage, and using your calculator, it's 16.6 repeating percent. Okay, and that would be probability. That is probably lesson 1, lesson 2 in chapter 11, but since we're skipping it, I just thought I'd throw that at you. All right, so what you're doing today is you're going to take the probability of not one event, like rolling a 3, you're going to take the probability of multiple events, so one after the other, okay? Looking down below, I'm going to just kind of scroll down. I got to tell you this right now, these notes are from 2 years ago, so they kind of jump around, so just follow me. I will try skip around and go in the order of your notes, okay? All right, here it says you can find the probabilities of multiple events, okay, occurring by using the probabilities of the individual events. So if you find the probability of one event and the next event, you can just either multiply them or add them. You'll see in just a second. To find the probability of 2 events occurring together, you have to decide whether one event occurring affects the other event. When the occurrence of one event affects how the second event can occur, the events are called dependent. Otherwise, the events are just independent events. They don't affect each other. I kind of thought, just to give you a quick, shot of what dependent would be, I thought I'd just draw you a little rectangle here and put, I'm going to call this my sock drawer. And in my sock drawer, I have at home 4 blue socks and I have 6 white socks. Okay, and if I wanted to know, are 2 probability events dependent? If I asked you, what's the probability I pick a blue sock right now, you would tell me 4 blue socks out of a total of, there's 10 socks in my drawer. 4 plus 6 is 10. So my chance of picking a blue sock is 4 out of 10. But let's say I don't replace the sock. I keep it in my hand, and then I go back in and I do another probability and I say, what's the chance I pick a blue sock again? Well, because I'm still holding the original blue sock I pulled out, now there are only 3 blue socks, and since I took one of the blues out, now there's only 3 blues. So the chance I pick a blue now is 3 blues out of a total of 9. So now, was the probability affected? Yes. It went from 4/10 down to 3/9. So these are dependent events. The probability will change. Now, if the probability doesn't change, if it stays 4/10 and then it goes to 4/10 again, that would be called independent events. And it matters because the answer, the formula you're going to use matters. So you need to know dependent versus independent. Dependent, the probability will change. Okay, this one just says classify each pair of events as dependent or independent. Part A. You select a coin at random from your pocket. Okay, and I thought I'd just go like this. A dime, a nickel, a quarter. Okay, at random from your pocket. So if I said, what's the probability you pick a nickel? Well, you would probably say 1 nickel out of 3 chances, 1/3. Okay, but you replace the coin. So once you replace the coin and select again, what's the probability you pick a nickel? Since you replaced the coin, it didn't change. And because it didn't change, we're going to call this one independent. Okay, this is an independent event. You tried to pick a nickel twice, you replaced it after you picked it, and the probability did not change. So it's independent. All right, this one, you flip a coin, then you roll a number cube to get a number. I don't know what number. Well, if I flip a coin, I mean, if I'm going for heads, the chance I get heads is 1 out of 2. Okay, and then I roll a die and I'm trying to get a 5. Well, by me flipping a coin, that does not affect the number I'm trying to get. So the chance to get that number is still the same thing, 1 out of 6. So again, this probability did not affect this probability. This is another independent. This is an independent probability problem. Okay, last one. Choose a marble from my bag. Keep the marble and then choose another marble from the same bag. So let's just, here's your bag. Let's say there's 15 blue marbles and there are 5 green marbles. So let's choose a marble from a bag. Let's say the probability of picking blue. Just looking at this, you'd say there's 15 blue out of a total of 20 marbles. So there's your probability. Keep the marble. Then choose another marble from the same bag. Let's do it again. Let's pick a blue. By me picking a blue and not putting it back in the bag, does that affect the probability of picking a blue again? And the answer is yes, because this turns into now 14 blues. So now the chance of picking a blue is 14 out of 19. So did the probability change? Yes, it did. So this one is called dependent. Okay? So there's your dependent event. All right? Hopefully that explains the difference between dependent and independent. All right, next page. All right. This one talks about a quick formula for the probability of event A happening and event B happening. Okay? It says if A and B are independent events, okay, so the probability won't change no matter what, then we follow this formula. And this word and, when you see what's the chance that this A happens and B happens, well, and in probability means to multiply. So what you end up doing is you take the probability of A times the probability of B, and you just get your probability over here, whatever that may be. So you multiply your two probabilities and you get your answer. Okay, these are independent events, these two problems going down. So it says, at a picnic there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips, 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you get a regular drink and regular chips? Okay, well, first of all, let's just write this down. It was a regular drink, so I'm going to go RD, and a what? A regular chips, okay? Regular chips, okay? The word and means to multiply your two probabilities. Okay, regular drink and regular chips, these are independent events. They have nothing to do with each other. So this is just a simple follow the formula right here and see what you get. Okay, what's the probability of picking at random now a regular drink? Well, there are what? 5 regular drinks out of a total of how many drinks? 15. Now 5/15 times the probability of getting a what? A regular bag of chips. Well, how many regular bags of chips do we have? There are 12 bags regular chips. So that's 12 out of a total of 20. Now, this probability times this probability is going to be your answer. Now, you can cancel if you want, or you can multiply straight across if you want, and then reduce later. I could just knock out the 5. 5 goes into 5 once, 5 goes into 24 times. Let's see here. I go 4 goes into 4 once, 4 goes into 12 3 times, and 3 goes into 3 once, and 3 goes into 15 5 times. I'm getting an answer on top of 1 times 1, which is 1 over 5. 1 over 5, the chance this happens is going to be 20%. Now these are independent events, so you just multiply the two probabilities and you get your answer. Okay? And I'm sure this is pretty simple for you, I hope. So using the same information from above, what is the probability that you get a drink, diet drink, and means multiply, fat-free chips? Okay, so the probability you get a diet drink times the probability you get a fat-free chips is, well, again, these are independent events. The chance you pick a diet drink does not change the probability of picking fat-free chips. So here we go. Diet, to pick a diet drink, there are 10 out of 15 times. To pick a fat-free chip, there's 8 out of 20. Now this time I won't cancel. I'll just multiply straight across and see if this is quicker for us. That would be 80 over, this is going to be 300. The zeros do cancel. You get 8 out of 30. I can reduce it. What goes in there? 4. Or sorry, 2 goes into 8. 4 times 2 goes in here, 15. I'm getting 8 4/15. The chance this happens is 4 out of 15, or better yet, 26.6%. Okay? All right, last one. What is the probability of rolling a 6 on a number cube and flipping a coin and getting tails? Again, rolling a 6 on a number cube is not going to affect the probability of getting tails. So these are independent events. So I can just multiply the two probabilities because they said what? They said the word and means to multiply the two probabilities. So what's the probability of rolling a 6 times probability of flipping a coin and getting tails? Well, tails, that's easy. 1 success out of 2 possible outcomes. Getting a 6 on a number cube, there's only 1 6, but there are 6 numbers on a number cube. So the answer is 1 out of 12, or what percent? I get 8.3%. Or 1 out of 12, same thing. Okay. These are independent events. Okay. All right. Now let's move on, I guess. Let's go to page 3. This is your page 3, but this is where the notes get kind of crazy. So be patient with me, because I think this is all I have to read to you is right here. Right there. Okay? It says 2 events. 2 events that cannot happen at the same time are mutually exclusive events. So they cannot happen at the same time. If A and B are mutually exclusive events, then the probability of A and B happening at the same time, okay, you gotta think of and. And means this event happens and this event happens at the same time. The chance that it says up here, they cannot happen at the same time, so the chance that they do happen at the same time is 0%. Okay? Just to give you a quick example of what that might mean, if I asked you this, now just please ignore the rest of this stuff, ignore this. But if I asked you, what's the probability of these two things happening? I want this and this to happen. All right, what is it? Let's try this. The chance, let's say I put, I'm just picking numbers at random. Let's say the chance I pick a number greater than 10. Okay, and not only is the number going to be greater than 10, it's going to be, pick on the same number. I want the same number to also be less than 7. So, what's the chance I pick a number greater than 10 and it's got to be less than 7? Well, I can't think of a number greater than 10 and less than 7, so this cannot happen. The chance this happens is what percent? 0. So if the event cannot happen, we call this mutually exclusive. So two events that can't happen because of the word and are called mutually exclusive events, okay? All right. Now, I got to flip forward and find where you guys are. You guys, I think, are right. Yes, I think this is you. Yep, you're right here, aren't you? Just kind of nod your head to yourself, I think. All right, to find the probability of either event A or event B occurring, you need to determine whether the events are mutually exclusive. You need to determine whether events A and B are mutually exclusive. Okay. All right. So, looking at this, the probability of A or B happening. Okay, now all of a sudden they throw what word in? They throw this word at you. It's the word or. So when you see the word or, you should be thinking, take your two probabilities and just add them. Okay, so what's the probability of A or B happening? It's the probability of A plus the probability of B. And then back here it says subtract the probability of A and B. So this would be the chance that both of them happen. Now it says here, if A and B are not mutually exclusive events, so if they're not mutually exclusive, then this formula takes place. Now this is not what we're going to do right now. We're not going to do this formula. We're going to actually go down beneath it and go here. If A and B are mutually exclusive events, what that means is they can't happen, these two events can't happen, then the probability of A or B will be the probability of A plus the probability of B. So when you see the word or, you think add your two probabilities. When you see the word and, you think multiply your two probabilities. Okay? All right, so let's just move on quick. Let's get this going. Here we go. Finding the probability for mutually exclusive events. Mutually exclusive events just means these two events cannot happen at the same time. Okay, so here it says, at your high school, a student can take one foreign language each term. So each semester you can take one foreign language. About 37% of the students take Spanish, 15% of the students take French. What's the probability that a student chosen at random is taking Spanish or French? The word or, that means we're going to add the probabilities. So what's the probability that they take Spanish, okay, or, whoops, I messed up, sorry, or what? French. Okay, the question becomes, why are these mutually exclusive? Because can you take Spanish and French? Can you take both classes? And the answer is no, this cannot happen. This is mutually exclusive. These two events cannot happen at the same time. Why? Because it said right here, at your high school, a student can take one foreign language each term. So you can't take Spanish and French. You can't take two classes, two foreign classes. foreign language classes. So this is a mutually exclusive event. So we will be following this formula right here, right here. This is the formula we follow when it's mutually exclusive. So all this is going to be is probability of taking Spanish plus probability of taking French equals. Okay, here we go. What's the probability of taking Spanish? 37%. It says it right up here. 37% of students take Spanish plus French. French would be what? 15% take French. Oh, there's not much to do here. Add them together, your answer is 52%. That's it. These are mutually exclusive. These two events cannot happen at the same time. Okay, this is the same problem. Not the same problem, but very similar. And it talks about taking 3 classes. Well, what 3 classes? Again, Spanish, French, or means to add your probabilities, Chinese, Mandarin Chinese. So what's the probability of doing all this? Spanish, probability of taking French, probability of taking Chinese, Mandarin Chinese. Okay, and you will get, if you read the problem up above, 37% take Spanish plus what? 15% take French plus 9% take Mandarin Chinese, which equals a total of 61%. Okay. These two problems were both or statements. When you see or, you think addition. When you see and, you think multiplication. Okay. All right. Whoops, missed it. Okay, here we are. This slide gets into, these are again or statements, probability of a square or a red, okay, red object, I guess. But when you look at this one, these all are not mutually exclusive. These can happen at the same time. So here it says this: suppose you reach into the dish at the right and you select a token at random. What is the probability that the token is a square or it's red? So here's what they're saying: probability that it's a square or it's red. Now, before you start this problem, you should say to yourself, is there a chance, is this a mutually exclusive event, first of all? Mutually exclusive means, is there a chance it can be a square and can it be red? Now remember, mutually exclusive means this can't happen. Can one of the objects be a square and can it be red? Well, I believe this is it. This is a square and it's red. Okay, so because of that, this is not mutually exclusive because it can happen. It can happen. You can get a square and it's red. So it's not mutually exclusive. So now we have to follow this formula. The formula says probability that you pick a square. Remember what or meant? Add. Probability that you pick what? Red. Okay. Then subtract the probability that it could be a square and it could be red. Okay. Now I think in just a minute here, or a couple seconds, you're going to figure out why we're subtracting this. What's the probability it's a square? Well, let's see here. I got 1 square, 2, and 3. I got 3 squares. Out of a total of how many objects? 9. So that would be 3/9 plus, here's my plus. Probability that it's red, I got red, red, red. This one's orange. I know you can hardly tell, but it is. So there are 3 reds out of 9. And then you have to subtract the probability that it happens to be square and it's red. Well, how many are squares and red? This one right here, just 1 out of 9. Now when you do the addition here, you get 6 ninths. Take away 1 ninth, you're down to 5 ninths. Now 5 ninths is about 55.5 repeating percent. Okay, I know I'm not looking at you, but I hope now that you're listening to this, the reason you subtracted this piece right here is because you actually counted this red square twice. You counted it as a square and you counted it as red. So you actually counted it twice, and that's why you had to subtract 1 off, because you've counted it twice in your probability. Hopefully that made sense, but that's why you take off the last part here, this and statement. You have to take off what you've counted twice. Okay, suppose you reach into a dish. I'm on the next problem. And select a token at random. What's the probability that the token is round or green? Well, probability that it's round or green equals the probability that it's round plus because of the or, probability that it's green, minus the probability that it could be round and green. Now, again, this is kind of like the last problem. I kind of have to look at the dish again, so I'm going to erase a couple things here. Okay. Now, if I look at the dish, the chance it's round is, I see 1, 2, 3, 4, 5 rounds out of 9, plus the chance it's green, 1, 2, 3 out of 9, minus, now, if this is mutually exclusive, these two things can't happen. Okay, round and green, I see round and green here, I see round and green there, so it can happen. This is not mutually exclusive. So when it's not mutually exclusive, you have to subtract off the two that are round and green. So that would be minus 2 ninths. Answer? Let's see. 8 ninths and minus 2 ninths is 6 ninths. And 6 ninths is 66.6 repeating percent. That's it. Okay. Once again, why did I subtract this piece back here? Why did I do that? Because you actually counted this one and this one twice. You counted it when you said, where is the round one? Okay, you counted the two of them. And then you counted the two of them again when you said, where are the green ones? So you've actually counted them twice, and that's why we're subtracting it off on the back side. Okay? Okay, last one. Here we go. Maybe you can shut me down now and just do it yourself and then turn me back on. All right, the numbers 1 through 10 are written on index cards and placed in a box. Okay? Here's your box. You've got 1. You got numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they're in a box. What is the probability that a card chosen at random has a number that is greater than 7 or even? So probability you pick a 7 or it's what? Even. Well, once again, or means add. So probability that's 7 times the probability that it's even minus the probability that it's 7 and even, right? Did I say 7? I think I did that wrong. It's greater than 7. My fault. Okay. So let's do it. I got to kind of erase a little bit. Okay, it's greater than 7, so greater than 7 or even. This one is also greater than 7. Okay, or even. Okay, now we got it. Oh, no, I don't. One more time. Greater than 7 and even. Okay, here we go. Here, what's the chance it's greater than 7? Well, what's greater than 7? 8, 9, 10 are greater than 7. So there's 3 of them out of 10 of them that are greater than 7. Plus, how many are even? 2, 4, 6, 8, 10. 5 are even out of 10. Minus. Now, if this was mutually exclusive, you wouldn't even have to subtract anything. But is there a chance there's a number in there that's greater than 7 and it's even? Well, what numbers are greater than 7 and even? I believe 8 and 10. So there's two numbers in there that are greater than 7 and even. This would be 3 tenths plus 5 tenths is 8 tenths. 8 tenths take away 2 tenths is 6 tenths. Answer is 60%. There you go. That takes care of our notes. I hope you filled them in. You have a worksheet to do. It is not, I don't think it will take you that long. Okay? Good luck on your worksheet. And play this over if you have to. That's it.